Now, related rates problems, you can be almost guaranteed that you'll see one of these on the free response section of the AP exam. And what's tricky about them is not the calculus, but it's just setting up the relationships based on the problem. Here we have air being pumped into a spherical balloon at a rate of 20 feet cubed per minute. And the thing to notice about this is that this is the rate of change of the volume of the balloon, right? It's getting bigger, more air is going into it at 20 cubic feet per minute. So this is the change in volume, or dV, over time. So dV dt equals 20 cubic feet per minute. At what rate is the radius changing? So what we want to know is dr, how much is the radius changing over time? And we want to know it at in a specific instance, when the radius equals 3. So the first thing we have to recognize is, alright, I want to know something about the radius. I know some things about the volume, so I need a way to connect the volume of a sphere to its radius. And that's where just knowing the formula for the volume of a sphere is important. Right? The volume equals 4/3 pi r cubed. Right? That's the volume for the radius of a sphere. That's the relationship between V and R. But I need to somehow get dr dt, or the rate of change of the radius, in here. And that's going to come from using implicit differentiation. We're going to take the derivative of our volume equation with respect to time. So the derivative of V is 1, but I'm taking the derivative with respect to time, so that's why I need 1 dV dt. The derivative of 4/3 pi r cubed, I'm going to use the power rule, so I'll drop the 3. So that will give me 4 pi r squared, and I took the derivative of r with respect to time. Now I have all of the components necessary to answer the question. I want to know dr dt. I have a specific radius in mind. I know dV dt. So I'll be able to solve 20 must equal 4 pi times 3 squared times dr dt. Or if I were to solve this for dr dt, this would be 20 divided by 36 pi is equal to dr dt. Right, and reduced, this would be 5/9 pi is dr dt. The rate of change of the radius at t equals 3 is 5/9 pi. And it's real important that you're comfortable writing your answer in this way. Right? The rate of change of the radius, and is it a constant? No, this is specifically when r equals 3 is 5/9 pi. And what are the units on this? Feet per minute. Right? In terms of the AP exam, this is the way we're looking for answers. You're very specific. This is the rate of change at a specific moment in time when r equals 3. And we've got the units. Right? Practice this habit in terms of giving your answer.